How do you turn this
into this?
I'm Anna Garliff, Communications Specialist with the Old Man Watershed Council. This video is part of a series that tells us where our water comes from, where it goes, and what happens in between.
Municipal watershed management is one of those in-between impacts. I'm Doug Kaup, General Manager of Water and Wastewater at the City of Lethbridge, and this is the science story.
In 1874, Nicholas Charan discovered coal along the Belly River, now known as the Old Man. His wife, Mary Brown, a native Picani, didn't need to discover it. Blackfoot had been using the coal and the river for thousands of years. Charan's discovery launched the settlement that would eventually become the City of Lethbridge. The Victorian ladies couldn't bear the name Belly and successfully petitioned to rename the river. As concerned as they were with the river's name, they actually had far greater concerns. It took less than 17 years for the Old Man to become so contaminated that people were dying of cholera and typhoid, both waterborne diseases.
So in 1912, town planners built our first wastewater treatment plant to stem contamination of the Old Man River and eliminate the threat of epidemics in the region. Even then, these planners knew the importance of water to our growing town with its rich farmland and semi-arid climate. Decades later, the plant was replaced to better mitigate the impact of population growth and industry was having on the river.
Today, Lethbridge has a population of about 95,000 people and thriving agricultural, commercial, and industrial sectors. The Lethbridge plant is one of the most advanced wastewater treatment facilities in Western Canada. To be clear, there are two treatment plants. One to clean the water that comes into the city from upstream, and the other is the wastewater treatment plant that treats the water from our drains before it goes back downstream.
This video will focus on wastewater treatment. The plant's treatment process begins with mechanical screening of the raw sewage. Anything bigger than a centimeter is removed. Next is grit removal, where aerated tanks remove sand and grit. Surprisingly, a lot of this comes from the janitorial work of washing floors, car washes. So after those two steps comes the primary clarifiers. At this point, the sewage is slowed down so heavier organic material can settle in the bottom. That's primary sludge. Versus everything that floats, including oils, greases, and light materials that don't actually belong down the drain. This lighter material is skimmed from the top, and the sludge is pumped off the bottom for further treatment. If left unchecked, these nutrients will promote algae and other vegetation in the river. Too much severely diminishes the oxygen available to fish and other species. Back at the plant, effluent now moves from the primary clarifiers to the bioreactors. The bioreactors contain three different environmental zones. First is the anaerobic zone with no oxygen in it. The lack of oxygen stresses certain types of bacteria so that in order to survive, they shed all the phosphorus in their cells. The second stage is the anoxic zone, where the bacteria begin hoarding any phosphorus within the effluent into their bodies. The nitrates are stripped of chemically bound oxygen, and nitrogen is released into the atmosphere as an inert, odorless gas. These two stages are kind of like Grandpa in the 30s. After having survived hard times, he starts hoarding things in the pantry. The third stage is the aerobic zone, where we add oxygen in the form of air bubbles throughout the effluent. This results in the removal of even higher amounts of phosphorus overall. The real innovation at the City of Lethbridge Wastewater Treatment Plant is the use of a patented process called Step BioP. The process repeats the 3 environmental stages 5 times and strategically adds primary effluent in a number of locations. This eliminates the need for the high-energy recirculation pump that is used at most biological nutrient removal treatment plants. The next stage is the secondary clarifier process, where the bacteria and water are separated. Then, the last stage of the liquid treatment is where the water is disinfected with UV light.
And this UV destroys the genetic code, the actual DNA in the bacteria in the water as it passes through.
Yes, so in a very short time, the UV prevents the bacteria from reproducing. The UV system at the City of Lethbridge Wastewater Treatment Plant reduces the bacteria discharged to the river by a factor of about 15,000. Before we began using UV disinfection, the City of Lethbridge was the single largest source of bacteria on the Old Man River.
After the UV treatment, the second stage of the wastewater treatment process is digestion of primary sludge and leftover bacteria.
Yes, solids are treated separately in anaerobic digesters. We use a gravity belt thickener to remove water from the wasted sludge. Digestion stabilizes the solids and reduces their volume through a variety of biological processes and generates methane gas. That gas is either sent to flare or to our cogeneration plant.
And the cogen facility is actually another state-of-the-art development for the Lethbridge plant.
Yes, the plant's 2 Caterpillar engines generate power and heat. Captured heat is recirculated to heat the buildings and the digesters. Combined, the 2 engines can create more than 1 million watts of power. Actually, these 2 engines can produce 60 to 70% of the on-site power requirement from methane gas that's produced in the process.
The Old Man Watershed Council works in close collaboration with the City of Lethbridge on research and projects that further municipal watershed management and health. You too can keep our water clean and clear for generations to come. Become a member of the Old Man Watershed Council. Sponsor a program, volunteer on a project, and be conscious of what you put down the drain. It takes a lot of effort to take it back out again. We are all downstream. Thank you for watching.